So in this lesson, we're going to learn how to write algebraic expressions. So first, let's look over how we translate words into math. So first, let's go over what we need to look for. So whenever we're going to translate an expression into a mathematical statement, we want to look for, in the statement, we want to look for things like numbers. Sometimes they're going to be written as words, but most of the time they'll be given as a number. We want to look for words that mean an operation. And we also want to look for any words that mean grouping. So let's look at this first one. And these are probably the easier ones that you're used to from probably earlier math classes. So it says the sum of 3 and 5. Well, numbers are easy. So like I told you before, I remember circle the numbers. And then let's look for the words that mean math. So the word sum means the answer to a math problem. So I would write this expression 3 plus 5. Okay, I'm not going to actually do anything because all I'm doing right now is just translating. Okay, now let's look at this one. 2 times the difference of 4 and 1. So let's find the numbers. 2, 4, 1. Okay, words that mean math. I see times, which means multiply. And I see difference, which means subtract. Okay, so if I go ahead and put it as is, I know I have 2 times, and then difference, 4, 1. But that's not what it means, is it? No. It says the difference has to go between the 4 and the 1. But does it mean if I do order of operations, I would do 2 times 4, and then I would subtract 1. But it says I have to subtract the 4 and the 1 first. That means I have to go ahead and I have to use parentheses in order to make it multiplying 2 by the difference of 4 and 1. So even though there is no word that specifically said I need to use a grouping symbol, the reason I have to use a grouping symbol is because 4 and 1 have to be grouped in order for me to make sure that I'm multiplying 2 by the difference rather than 2 times the 4. Okay, so this one's just stated as a question. What is the quotient of 6 and 3? So, numbers, words, quotient. So, 6, quotient means to what? Divide. So I could write it like this, or I could also write it like that. Now, there's lots and lots of ways that we could go ahead and we could talk about all the different ways we could go ahead and write math statements. It would be a very exhaustive list. So we're not going to be doing that. We'll do that in class again. So let's talk about creating an algebraic expression. So remember, algebraic expression means that it includes at least one variable. So when we're looking at an algebraic expression, we, in addition to looking at what we were looking for before, numbers, words that mean numbers, words that mean operation, words that mean grouping symbols, we also want to make sure that we're looking for words that mean an unknown value, something that tells me I have a number that I actually don't know what it is at the moment. So let's look at these. So these are some simple ones. So this says the product of a number and 4. But does it say what the number is? No. And there's my math word. So I need a variable to represent the number. So I pick one. So let's say h equals a number. And so now I want to write the product of 4 and a number. So remember, a number next to a variable with no operation between means multiplication. So this means 4 times a number, and we're using h as that number. Okay, so now we have twice the difference of a number and 7. So the numbers are 7, a number, and you see another one? Twice. But the number twice also is a math operation, and so is difference. So remember, the word twice tells us a specific math operation. And remember, it means multiply by 2. Difference means subtract. And so now we need a variable that's going to represent our number. So let's go ahead and pick a one. Let's do y. We use hashtag for number. Okay, so it says I need to multiply 2 by the difference, and remember we just talked about this, of a number and 7. So a number and 7. But remember, I don't want to multiply 2 by the number. I want to multiply 2 by the difference. Okay, third one. Samaya is 3 years older than her brother. So I want to represent Samaya's age. So I need to know her, even though there's nothing in here, I have 3 years. And what tells me the math? It's the older than. That means her age is greater or bigger, which means addition. And then what's the unknown? It's her brother. So that's my other number. So let's go ahead and use a variable for her brother, p. Okay, so if I want to represent Samaya's age, I'm going to go ahead and I'm going to say Samaya is 3 plus b. So if her brother's 7, Samaya would be 10. If her brother was 12, Samaya would be 15. So it says Miss Shannon needs a table for her kitchen that is rectangle shaped. She wants its width to be 4 feet, but the area cannot be more than 32 square feet. What are some different table dimensions she should shop for? So I'm going to draw a picture. And so this is what we call modeling the problem. So what do I know? Okay, it says there's 4 feet is the width, and it says area is 32 square feet. And the question that we're trying to, also very important, it's rectangle shaped. And it's wanting us to figure out, we want some different table dimensions. Remember, dimensions are what are the lengths and the widths possible types that we can go ahead and use. Okay, so now we know that the width is going to be 4 feet no matter what. But the area can't be more than 32 square feet. So what do we know about area? We know that to get the area of a rectangle, we do length times width. And we know for us that the width is always going to be 4 feet, but the length can be whatever we want. So if we use our variable L to be the length, and we're multiplying by 4, we just need that number to not be more than 32. So what are some different dimensions that we could have for our table? So we could go ahead and we could say, what is the area that we get for the different lengths? Well, if we chose 1 feet, then 4 times the length would be 4 times 1, which is 4. A really small table. If we chose a table that was 5 feet long, 4 times 5 would give us 20 square feet, which is a pretty big table. Say we chose one that was 6 square feet. 4 times 6 is 24. So it's still meeting our criteria because it cannot be more than 32 square feet. What if we chose one that's 8 feet long? 4 times 8 is 32. So that still fits. So what if we chose one that is 9 feet long? So 4 times 9 is 36 square feet. And that would not meet our criteria of the area not being more than 32 square feet, which means we can have a table that is up to 8 feet long. Okay, so in this one, let's see what happens with our variable here. So Jamie gets paid $15 number for the first hour of babysitting. After that, he gets paid $7 per hour. Okay, and we want to go ahead and we're going to find an algebraic expression that helps us figure out how much Jamie gets paid for a night of babysitting. Okay, so let's go ahead and do this model a little different. So we're going to go ahead and we're going to build an expression that shows Jamie's paycheck. Well, probably not a paycheck when you babysit, but the cash that he gets. Okay, so here he is, and he gets there and up to 1 hour. And then he has a different pay that's more than 1 hour. So if he's there up to 1 hour, he's going to get $15. Exactly. And if he's there more than 1 hour, he's going to get $7 for each starting at hour 2. Okay. So, what if he works only 1 hour? What would he get? What if he works 2 hours? What would he get? So he would get the 15 plus 7 more, which makes 22. If he works 3 hours, what would he get? He would get 15 plus 7, which is 29. Okay, but we're trying to build an algebraic expression. So how can we go ahead and figure this out? Okay, so we know that what's changing is the number of hours that he worked. So that's our variable. So we're going to let H equal the hours worked. So we know that to get the 15, he had to work 1 hour. Right? But do we put a variable in for that? That's the question. Plus, and we know that he's going to get $7 for the number of hours worked. And is it the same variable? So let's see. Would we get, with this expression, would we get $29? So if we did 15 times 3 plus 7 times 3, we would get 45 plus 21, which is not 29. So that doesn't work. So let's go back to our model and see if we can figure this out. So when we're going ahead and we're doing this, how many times do we actually go ahead and include our 15? Okay, is the 15 something that we need to go ahead and give him only one time? Or do we need to give him more than once? Well, this is a one-time deal. Gets it just for showing up, basically, because it's for his first hour of time. And we know that he's going to increase his pay from $15 for each hour starting after the first one. So he's just going to get the 15. And then he's going to get more. So is our expression this? Let's check. So if it's that, if we put in the 3, we should get 29 for H. I'm sorry. So 15, 7 times 3 is 21, and 15 plus 29 is 36, which is not 29. So that's not our expression. So what's the difference? Well, remember when we go ahead and we did this, remember he's only getting $7 for each hour after hour 2. So even though he worked 3 hours, we have to deduct 1 hour because remember he got paid $15 for that one. So it says after hour 2. So this is saying we have to take 1 hour away. And that's something that's not specifically stated in the expression, in the problem that we were given, but it's implied. So let's see if this one works. So if this is a correct expression, then we should be able to get 29 now. So 15 plus 7 times 3 minus 1. That'd be 15 plus 7 times 2, which is 15, plus 14, which is 29, which is what we got. Okay, thanks.